All right, here we are. Section 10.3, page 3. We're looking at 8 examples of simplifying expressions. Hopefully I've got enough space on the board to work on these, so we'll see how it goes. All right, let's start with the first one. 6 times the square root of 50. What are the perfect squares of 50? Perfect square factors of 50. I think 25 is the biggest one. So this is going to become 6 times the square root of 25 times the square root of 2. Yep, and then I just have to simplify what I can simplify. Square root of 25 is 5. So I've got 6 times 5 times the square root of 2. And 6 times 5 is 30. So my final simplified result is 30 times the square root of 2. Okay. All right, this is very similar to the last one. Perfect square factors of 18. That's going to be 9. 9 times 2 is 18. So 5 times the square root of 9 times the square root of 2. Square root of 9 is 3. And so I'm going to have 5 times 3 times the square root of 2. And 5 times 3 is 15. So my final answer is going to be 15 times the square root of 2. Okay. All right. This next one, this is where I'm afraid I might run out of space a little bit. So try to stick with me. What I'm looking for is I'm looking for perfect cube roots, or perfect cubes that I can factor out of 40. Perfect cubes that I can factor out of x to the third, and perfect cubes that I can factor out of y to the fifth. And then I'm going to kind of break them apart, simplify stuff, and put it all back together. So for 40, 8 goes into 40. So I can say this is the perfect, or the third root of 8 times the third root of 5. Okay? That's what I get when I break up this. Okay? X to the third is already a perfect cube. So I'm just thinking the third root of x to the third. And then y to the fifth, a perfect cube that I can pull out of that would be y to the third, right? So if I do that, I get cubed root of y to the third times the cubed root of y squared, okay? So what I've done here is I've just taken that original thing and broken it up into all of its different pieces, and now I can start to simplify and put it back together. Okay, starting with, what is the cube root of 8? Well, the cube root of 8 is 2. Okay. What other pieces here have perfect, so this is not going to simplify any further. So I'm going to leave that alone. The cubed root of x to the third is x. So I can put that there. And the cubed root of y to the third is y. Okay, so I can do that. Now, I've simplified everything I can simplify. The only things that I haven't gotten to yet are this and this, okay? But they're both to the third root. So what I can do is I can put them under the same radical as I put this back together. It's going to be the third root of this times this. Okay. So a lot happened there. We're going to do another one very similar to it here. But that's the kind of process for one like this. Okay, now I can sit back down. All right. Yeah, let's do the same process with here. Okay. This time I'm looking for perfect fourth roots that I can factor out of each piece. Fourth roots are things like 1 and 16. Yeah, so 16 is the biggest one I can pull out of 32. So I'm going to say I've got the fourth root 16 times the fourth root of 2. Okay. Perfect, what I can take out of a to the 10th are multiples of 8. So I can take out a to the 8th. So I've got the fourth root of a to the 8th times the fourth root of a squared. Okay, and then for b to the 19th, multiples of 16. I could take out b to the 16th. Wait a second here. This is going to have to go for a second. Okay. Yeah, fourth root b to the 16th times the fourth root of b to the third. Okay. All right. So I've broken everything up into its, into its pieces. Now I can start to simplify and put everything back together. Okay. Fourth root of 16 is 2. Fourth root of 2 I can't do, so I'll come back to that later. Fourth root of a to the 8th, that's a squared. Fourth root of b to the 16th is b to the 4th. And, all of this stuff I can't do anything with because it can't be simplified. So then, with those things I couldn't simplify, I put them back together under the same radical. Since they all have the same index, I can do that. And then I just put all of those radicands. Okay, and it looks like this. 2a squared b to the 4th times the fourth root of 2a squared b to the 3rd. That is that. Okay? All right. These next two, okay? What's interesting, and with these ones here, don't forget the order of operations, okay? And don't forget about things you can do before you start taking square roots, right? So I look here, I've got a to the 7th over a to the 3rd. Well, what is a to the 7th over a to the 3rd? It's just a to the 4th, right? So this, before I even get into any radical stuff, I just simplify that fraction. And now I've got the square root of a to the 4th. Now this isn't how I did it on the notes that I wrote in the that I put in the classroom site. I realized after I did that there was a much easier way. So here's the much easier way. Yeah, and what is the square root of a to the 4th? Well, the square root of a to the 4th is just a squared. That's that. That's all there is to it. Okay. Same situation here, right? We have the square root of 81 over 3, which in the notes that I posted, I did all of this extra stuff, when I really could have just noticed that 81 over 3 equals 27. So really what we're dealing with here is the square root of 27. Okay? What's the square root of 27? Well, you got to factor out a 9 and a 3. So that what we end up with here is 3 times the square root of 3, which is the answer that I got. It just took me a lot longer to get there. Okay. Now, we got 2 more left on this. I'm going to erase. I keep wanting to ask, is it okay if I erase, but then I'm remembering that you're not even there. And then you can pause the video, so I'm just going to keep going. These last two. We got 7 times the square root of 50 over 10. Okay, what's the deal here? Well, I gotta simplify the 50. That's gonna be 7 times the square root of 25 times the square root of 2. And just because I'm gonna actually factor out the 10. Just like in that previous unit where when we're simplifying, it sometimes helps to just factor everything. I'm just going to factor 10 into 5 times 2. What is this going to be? Well, square root of 25 is 5. We've got 7 times 5 times the square root of 2 over 5 times 2. And now you can see that what's gonna cancel here are those 5s. Okay, be careful here. Don't be tempted. This is the square root of 2 and this is just 2. Those do not cancel. So my final simplified result is 7 times the square root of 2 over 2. Okay. All right, one more to go. Works exactly the same way as the one I just did. We've got 2 times the square root of 300 yeah, over 30. Okay. All right. Perfect squares that come out of 100 or that come out of 300. That of course is the square root of 100 times the square root of 3 over 3 times 10. Square root of 100 is 10, so I've got 2 times 10 times the square root of 3 over 3 times 10. And look what happens. The 10's cancel. The square root of 3 does not cancel with 3, so I just get 2 times the square root of 3 over 3. And that's a wrap. Have a good day, folks.